Our observable universe is about 93 to 94 billion light years across. There are two theories about what we would see if we got there in a spaceship. One is that we wouldn't be able to get there. If we go there, we will end up back where we started. But another theory is that we might not end up anywhere. We will just keep going through the blackness for eternity, and our journey will never end. What lies beyond the observable universe has long been a mystery. Is there another universe after it? Or is this the end of our huge universe? But the observable universe is not the only mystery of this universe. There are many other such mysteries in this universe. So, I am Saurashis Chakraborty, you are watching Astro Saurashis. Today we will learn about 4 mysteries that scientists have no answer to. Without wasting time, let's get into it. We all know that our vast universe began with an explosion, also called the Big Bang. This Big Bang occurred 13.8 billion years ago from a hot, dense and a tiny point, also called a singularity. From this point, space-time, matter and energy began expanding outward, creating the universe we see today. We don't know exactly how the universe began, but this theory is considered the most accepted. There are many problems there too, such as what was there before the Big Bang and what caused it. But the biggest problem is why the Big Bang happened. There are many theories on this topic. For example, some scientists think that quantum fluctuations are the reason why the Big Bang happened. Now we may be wondering what quantum fluctuations are. Quantum fluctuations are temporary changes in the amount of energy at a point in space due to the uncertainty principle. They cause virtual particles to pop in and out of existence, making space wiggle at the quantum level. This phenomenon plays a key role in processes like the early universe's inflation and the Casimir effect. These fluctuations might have caused the Big Bang, leading to the birth of space and time. Some scientists are hesitant to accept quantum fluctuations as the definitive cause of the Big Bang, due to several scientific and philosophical reasons. Quantum fluctuations are well understood in the context of our universe, but applying them to the origin of the universe is highly speculative. The conditions before or at the Big Bang might not follow the same quantum mechanics rules we observe now. On the other hand, at the Big Bang, space-time is thought to have emerged from a singularity, where classical physics breaks down. Quantum fluctuations operate within space-time, so it's unclear if they can explain a state where space-time itself didn't exist. Our universe might not be the only one. There could be a multiverse, a collection of many universes. Some theories suggest our universe was born when 2 other universes collided or separated, triggering the Big Bang. On the other way, some scientists think the universe could go through cycles of expansion and contradiction. The Big Bang might have been the result of the collapse of a previous universe. Despite so many possible theories, we still haven't figured out exactly what caused the Big Bang. You may know that our galaxy, the Milky Way, has a massive black hole at its center, also known as Sagittarius A star. As you know, black holes have enormous gravity. The largest black hole we have found is called TON 618. If you compare our solar system to this, our solar system would look like this near TON 618. Did you find it? Here. But what is inside a black hole? The event horizon is the point around the black hole where the pull of gravity becomes so intense that nothing can escape. Once something crosses this line, it's gone forever. We can't see inside the black hole because light can't escape from it, which makes it black. At the very center of a black hole, there's something called a singularity. It's the point where the gravity is so strong that it crushes all the matter and energy into an infinitely tiny space. We don't really understand what happens in this point because the laws of physics, as we know them, break down here. Inside the event horizon, all we can say for sure is that gravity becomes incredibly powerful. Time itself even behaves differently. The closer you get to the singularity, the slower time would appear to pass for you compared to someone far away from the black hole. Scientists can't say for certain what happens at the singularity because the laws of physics can't explain it yet. It's possible that the singularity holds the key to understanding how the universe works at a deepest level, but we can't observe it directly. By now, you must have understood how big our universe is. At the beginning of the video, I said that the observable universe is about 93 to 94 billion light years across. We don't know what's after that. Maybe the universe will continue to exist. But in such a big universe among so many stars, is there no life on any planet? If so, why aren't they contacting us? Why can't we find them? This problem is known as Fermi Paradox. The universe is about 13.8 billion years old, and our solar system is just 4.5 billion years old. This means there has been plenty of time for intelligent life to develop elsewhere in the universe, even long before humans came into existence. Despite the high probability of alien life, we haven't detected any signals, spacecraft, or other forms of communication from any intelligent civilizations. This is what makes the Fermi Paradox so puzzling. The universe is so big and old, and yet we are nothing. There are some possible solutions to this paradox. Some scientists think the vast distances between stars make communication or travel very difficult. Even if aliens exist, they might be too far away for us to reach or hear from, or our technology might not be advanced enough to detect alien signals. Maybe aliens are using technologies far beyond ours, and we don't know how to detect them yet. A more somber theory is that intelligent civilizations may inevitably destroy themselves before they have a chance to communicate or travel to other stars, whether through war, environmental collapse, or other means. It's possible that Earth is one of the first planets where intelligent life has developed, and that the universe is still waiting for other civilizations to emerge. We have no answers. Anyway, we now have a plausible theory of how our universe began. But will our universe last forever, or will it have an end? If you think this universe will last forever, and then you might be wrong, because you know that our universe is gradually expanding, meaning that the objects you see in the night sky are gradually moving away from us. You see the Milky Way like this in the night sky today, but your parents used to see the Milky Way like this. Did you notice anything? If you still don't understand, let me tell you what the Milky Way will look like in 2050. Do you understand now? They are all gone because space is expanding, and according to scientists, for some strange reason, the speed of this space expansion is increasing. If everything keeps moving away like this, then according to scientists, we are going to fall into the big freeze theory. It suggests that as the universe continues to expand, it will eventually reach a point where stars burn out, galaxies move too far apart to interact, and the universe becomes extremely cold and dark. In this scenario, the universe keeps expanding forever, and everything fades into a state of maximum entropy, where no usable energy remains. So, is this how our universe will end? However, some scientists believe that at some point our space will expand and then reverse, and everything will come together again, and the universe will begin anew with the Big Bang. Just as we don't know how our universe began, just as no one knows the real answer to how it will end, it remains a mystery. So, be sure to let me know what you think about these mysteries in the comments. I hope you enjoyed today's video. If you want to see more, subscribe to Astrosources. See you with another amazing video. Stay well and stay healthy.